this for the cut reel. Yeah. Hi, everyone. This is Jay from Interview Query. Today, we're doing a mock interview with Sergey. Sergey has worked in data science for countless of different companies with many years of experience at places like Grubhub, and currently he is a data science consultant. Sergey, welcome to the mock interview. I'd love for you to just talk a little bit about your background and how you got into data.
Hi, Jay, and thank you. So I grew up in Russia, in St. Petersburg, and there I did a lot of programming competitions, such as ACM, ICPC. My team actually did very, very well in it. You can look it up. And after that, I didn't just want to get a job as a programmer. So I moved to Pennsylvania, and I got a PhD in pure mathematics from Penn State University. And then I thought, why don't I go to Wall Street and try to make some money? So I worked at Credit Suisse for a couple of years. We were doing options trading and the market making desk. And after that, I've been on and off with various startups. I had one moderate success, whereas we had a startup exit. Seamless Grubhub bought our startup called Basque Labs because of the food recommendation system I actually created myself in Python. And then it was an act to hire, so I worked a little bit, more than a year actually, for Seamless Grubhub after that. And ever since, I've worked with other startups in various capacities, from CTO to consultant to data scientist.
Awesome.
All right. I see, let's say we have a group of friends.
Yeah, so let's say we have a group of n friends represented by a list of dictionaries where each value is a friend's name and their location on a three-dimensional scale of X, Y, and Z. Friends want to host a party, but want the friend with the optimal location, the least distance to travel as a group, to host it. So write a function to return the friend that should host the party.
Okay, by optimal location, you mean the sum of locations that each person has to travel, right?
Yes, is the least amount.
Okay, let's see if there is. So, I mean, we can do it in the naive way, obviously, just compare each option. Okay, so you want me a new function? Right, so we'll say for potential host in France, we'll compute cost, we'll do something, right? So here we'll say best host equals none, best cost equals some big number. And just we have to assert. Okay, we can be explicit. So in the end, we will return. I think you only want the name, right?
Let's say name and just distance.
Okay,
yeah, sure.
So just the whole thing.
Yeah, whole thing.
Okay, good. So for something we compute the cost, now we say if you have any tie-breaking preferences.
Yeah, it doesn't matter. First one.
Okay, fine. Yeah. So now here we can just add up all the distances. We don't have to exclude the person just because it will be 0.
Okay.
Right. So basically, sure. Okay, it won't be. It will be a little faster if we use some libraries here because we're going to do a lot of indexing, right?
All right.
So, but essentially we can do just, will be a sum of something, right? So we'll say for person in France, we have to do, okay, I will not do a new function, just, you know, just to make it a little faster and avoid a function call. So here we're just putting a distance essentially between person and potential host, right?
Yep.
So, okay, I want to have a variable, honestly. Hostel. I don't want to index it there every time. Location. Right, so here we have person, we have person location 0. Right, so we have, that's so long. Okay, it's called L. L 0 minus this. Okay, I'll just spell it out. How many parentheses do we have here? Plus L1 minus person location 1 plus L2 minus person location 2. Okay. Okay, that's it.
So for each person, you're computing the cost. But are you doing it for n friends, or is it just for the? Oh, is this for the index of the value? Gotcha. Okay. So what's the runtime for this? And can you run it?
So it's the it's square number.
It's a square number. Is there any way to make it faster or not?
So I have to think about it for a second.
Okay.
Can you host a party in the middle of space? You can't, right?
No, it has to be at one person's house.
Okay. So let's say they're in a line first, right?
Okay.
Let's say everyone lives on a line. Now, everyone lived on a line. I think we have to pick one of the middle friends, most likely, because otherwise, yes, because otherwise it will be better to shift one of the middle ones.
Yep.
So for example, if you have 3 friends, you have to pick one who is in between the other 2, because otherwise you can only gain from shifting.
Yep.
The middle one. However, it doesn't quite work with a lot of friends. So can we do here? Let's see. Okay, so it is a continuous function. Okay, it's a continuous function. Is it changing quickly? It's not changing too quickly, because let's say I take some point in space, and let's say I compute this function for every point in space. You know, the sum of distances, right? Then its derivative is bounded. Its derivative is bounded by n, in fact, if you move around. And because for distance to a particular point, its derivative is bounded by 1.
Okay.
I mean, it vanishes. It's not, the derivative doesn't exist, of course, at a point with the friend, but elsewhere it's bounded by 1. So the sum is bounded by n. Okay, so that's a function with a limited derivative. So we could try to apply some numerical methods, such as, so let me see. Where does it change? It gets tricky. It gets tricky. It gets tricky. Look, you could try to get an estimate. Let's say you have a lot of friends, right?
Yeah.
Let's say you have like 1 million friends, right? You could get an estimate. I could make a net, say 100 by 100.
Yeah.
Of 10,000 points, and I could just compute a solution for every vertex of the net, right? And then like a grid search, a grid, right? You understand what I mean?
But isn't that still n squared?
No, again, if I say I have 1 million friends.
You have 1 million
right?
friends. Yeah.
Right, and they all have coordinates between, say, 0 and 1.
Okay.
So I take the cube 0 and 1, I divide it, let's say I divide it into 1,000 pieces, 10 times on each axis. And then I get 1,000 nodes. This 1,000 has nothing to do with the n, it's a constant. Right? And then I compute for each node in this grid, and then I narrow down to the points where I have smaller values, and I do some grid search near it.
Gotcha.
Right, so it could be, it could potentially give me a practical solution faster. It's not an exact solution.
Okay, so let's add a constraint, and let's say that for each value in each one of these indexes, they can only go from 0 to 100. Does that then work for that scenario you just?
Well, if they can only go 0 to 100, then you can always solve it in million times n, because you only have 1,000,000 points.
Yeah.
And you could, you could apply optimizations after this. I don't remember if there are theoretical, because if it was square distances, I would be more suspicious that there is a theoretical way to significantly optimize it. But for regular distances, I don't remember if there is a strong theoretical reasons for us to rule out many of those. You could also try things along the following lines, like take a random line that splits the group in half. Take a random line that splits the group in half and try some points on this line. Okay, maybe project some, okay, take a random line that splits the sets in half, project everyone on this line, take the median of all those points on the line. It should be a pretty good solution in practice, intuitively.
Okay. Was there a way to easily code it out, or is that theoretically too complicated?
Yeah, I mean, what do you mean by easily?
Like within 5 minutes?
Within 5 minutes? Man, okay. Within 5 minutes. So we have n friends, and we want a random line, right? So random line is just ax plus by plus c equals 0.
Okay.
So, okay, we take a random number. Random number is what? NP, what is it? Random.random, right? You multiply it by 2 pi. You call it an angle. That will be the direction. Then we take cosine of phi, and that will be a. B will be a sine of phi. Right, so now we have a random line. Now we needed to divide things in half. Right, so we need to do a, it's a plane. I'm sorry, we need a plane, right? We need a plane. How do we need 2 angles for a plane? How do we do this? So how do we get a random point on a sphere? That's an excellent question. Okay, let's pass it for now. Let's say we figured it out, right? Let's say we figured out how to get uniformly random direction. BC is uniformly a random direction on a sphere. Now you need to find D. Now we do binary search. We take D min is minus infinity, D max is plus infinity. Now you say while the max minus the min is greater than, say, I don't know, something, maybe an overkill, you have to do this. Now you do A times person location 0 plus B times person location 1 plus C times person location 2 plus d, right?
Yep.
So we need to take greater than 0. We take sum of this. We say if this is too small, if this is too small, we need to help it to be positive. We say d equals d min, else we need to go the other way. So now it splits in the middle, the plane. Now the plane splits in the middle. Wait a second, but now with the plane, even if we project on the plane, we still have to find it on the plane. I thought, actually, I was just solving it on the plane, not even in space. You see the problem, right? Now, if I project all the points on the plane, I still need to do more work. What if, what if I just tried it 3 times? Look, let's do something easier. Look, we can just take, frankly, we can just take the center of mass, just find the point closest to it. You know, that's much easier. So we'll just do sum of person, location, I wish it were just numpy arrays, frankly.
Yep.
Okay, np dot array person location. I can probably do this in France, then do this center. Right now we just need to find the closest one, right? So we just do the thing as above. I don't remember how to use argmin. You either Google argmin or you just do a for loop, like above. For p, you know what I'm going to do. For p in France, you know, this to center. You don't have to do a square root here. Is person location 0 minus center 0 squared. Okay, look, I just write sum just because I don't want to write, but it's not optimal. For I in range 3, we can just optimize sum of squares. If this to center less than best dist is this to center, best friend, best host equals p, you know, best dist is this, best host is none, return best host. Okay, so this will be our heuristic def big host heuristic.
This is O of 2n then?
O of n, yes, this is linear.
Can you run it?
I don't know, can I run stuff here?
Yeah, you can.
You mean on the right? I paste to the right?
You could paste to the right or run the code, but then you have to put it outside of the comments.
Okay, fine. So what do I do now, friends?
Yeah.
Name location is not defined. Okay, fine.
You didn't put a. Okay, try that.
Okay, I'm curious if it will give us the same answer as the other solution. Big host heuristic friends.
You can input, yeah.
Big host heuristic friends n equals len friends. I should have used len friends. Oh, come on. Name person is not defined. Okay, p probably. Right. Okay, and now what if we do this one? Why it doesn't work?
You shift enter. Right.
Okay, some alignment issues. Cost equals sum of method security of. Maybe I forgot another bracket. Oh, come on. What is it complaining? Must be a real number, not generator. Come on, sum of.
Did you close
Okay, I
the
put the parentheses in the wrong place. Seriously.
Yeah.
And support the type. Okay, because something is person location 2, person location 0, and support the type minus. I'm subtracting.
It's
What
not
is
location.
L?
You have to do friends location.
Oh, terrible.
28.
Potential host. Big host friends. Best host equals, okay, not host. It's like potential host. Oh, interesting. Scalar better. Let's see. Scalar is at like.
I think it was David. That's what I thought.
Well, let's see. So scalar and 3, 5. We have to just compute it. We should return. Let's return also best cost.
Yeah.
Big host. And okay. But there I'm not. I have to return SQRT. Really. So it says David is better.
Yeah.
Is something wrong here? Okay, I forgot to square, you see. Interesting. Wait, so is it 27 or is it?
I think it's square root. You got the square root on that one, and then you didn't do the square in the top one.
But I am in the top one now.
Pick
sum of wait, sum of square roots, not square root of the sum.
Square root it again. Yeah.
Come on. Okay, fine.
Cool.